Hello everyone, thank you very much for having me at the DEFCON Delhi Security Conference. So this talk is going to be about Docker for bug bounty hunting and penetration testing in general. All right, now before we actually get started with anything, I just want to clear up a few things regarding what I'll be covering in this video. So of course, I'll be taking you through setting up Docker on Linux and the various commands that will help you get started and effective. So we'll be talking about the tools and the environment, and then we'll move on to setting up a hacking lab with Docker. And again, I'll show you how to use various toolkits that you can use for your bug bounty assessments and any of your penetration tests. All right, so let's get started. First of all, if anyone of you has never heard of Docker or hasn't used it, Docker is essentially a system that allows you to build and deploy applications and services in the form of containers, right? So an easy way of looking at this is comparing it to your typical hypervisor like VirtualBox, where you have virtual machines. So I'll get to the comparison in a second. So it is a platform as a service offering that utilizes the host operating system kernel, as opposed to typical hypervisors like VMware and VirtualBox, right? So instead of actually utilizing VMs and the typical VM infrastructure, they all of the containers, which is the name of the actual virtual machines or the isolated VMs, all use the host operating system kernel. This will become much easier to understand in a second. So the containers are what you would call like VM templates or VMs, right? So the containers contain the dependencies and the libraries that the application or service needs to run, therefore eliminating the need for installing dependencies and managing the operating system or managing an entire other operating system. And Docker containers are much more efficient than VMs, as they utilize the host kernel as opposed to virtualizing an entire other operating system. So just to explain this really simply, let me just take you through a bit of a history with hypervisors and virtualization technology, just to show you how great Docker is. So let's start off with a simple example where, if you're usually in the early 90s, the early 2000s and the late 90s, companies started utilizing applications, it could be mail servers, hosting their own websites, web applications, so on and so forth. And so companies started migrating or started utilizing the internet for business, right? Which meant they now needed to buy servers so that they could host these applications, the mail servers, so on and so forth. So typically what would happen is that the IT team would look around for servers that they would want, and they would buy an entire server rack, and based on their requirements of the application, they would then buy one with the appropriate resources. But in many cases, what happened is they would buy a much more powerful server than they actually needed, and what would happen is that utilization would remain low throughout its lifespan, and the application would only account for maybe 5 or 10% of the overall system resources. So people would always buy things or servers that were more powerful, because it was really difficult to predict load and what type of load you'll be expecting. So people would always buy the most expensive and the most beefed up versions. And the obvious problem here is that there was underutilization of these resources, because these servers would essentially just sit in the server room or in a closet somewhere, and they would only be running one application. So this was highly inefficient. So that's where companies like VMware and later on VirtualBox from Oracle came in, and they introduced hypervisor technology, which allowed you to host more than one operating system, which means you can now host more than one application on the same server, which was really great, because now they could host their mail server, they could then host their web application, and again, you could host a Linux box, you could host a Windows box. So for example, if they were running their mail exchange service on Windows server, they could host a VM with Windows server, and if they were running their mail server using Ubuntu, they could host that separately. And that means that system resources were now being utilized much better than they were before. However, the obvious issue here, or the obvious problem, was that with these hypervisor solutions like VMware and VirtualBox, you had to virtualize another operating system, which means those resources, or half the resources, will be consumed by that other operating system and then the rest is left to the application. So for example, if we take a look at this image here, you can see exactly what I'm talking about. So here we have our containerized applications, and I'm talking about Docker, and the other containerized solutions are LXC, which is Linux containers. And here you have your typical hypervisor infrastructure, which you can now understand what I'm saying. So you have your hardware infrastructure, and then you have your hypervisor, which is VirtualBox or VMware, and this is obviously running on the host operating system. And then you have your virtual machines. Now the problem is quite obvious here. You can see that the guest operating system that you're virtualizing is taking up more than half of the resources that you've allocated to that virtual machine. So for example, if you were hosting a Windows 7 VM, half of it would go to hosting the operating system, and the rest will be left to the application. So that's highly inefficient, because the app then is left with what's left over. And again, this was another form of inefficiency that many people were talking about, because you essentially had to host entire other operating systems, and then what comes with that is the additional cost of licensing for these other operating systems, and then you need to manage those operating systems. You need to have administrators constantly patching them, so on and so forth. Now with Docker, what you have is you have your hardware infrastructure, you then have your host operating system. In this case, in the case of this presentation, I'm going to be talking about Linux. You can run Docker on Windows to host Windows containerized applications, but that's beyond the scope of this talk. And so again, you have your host operating system, which can be Ubuntu, Fedora, it really doesn't matter. And then you have Docker, right? Docker runs, the Docker daemon runs right over here on top of the host operating system. And then you have your containerized applications that are all using the host operating system, right? So they're all utilizing the host kernel right over here, which means you do not have to virtualize entire operating systems. So what does that mean? That means, number one, they're faster loading speeds and startup speeds. Secondly, much better system resource consumption and utilization. And you can see in the case of these two, both of these setups have the same hardware infrastructure and configuration, which means, for example, they both have 8 gigs of RAM, dual core CPU, and you can see that in the case of containers, you can run more. You can actually run twice the amount of containerized applications than you can VMs with the same configuration. So it's a much improved efficiency. Now that we understand the difference between Docker and traditional hypervisors, we can actually start taking a look at the advantages of using Docker for pen testing and bug bounty hunting. Right. So as I've mentioned, Docker works on Linux, Windows, Mac OS. So it provides you a multi-platform solution or base for running containers. So you can run your tools and environments on multiple operating systems. And because of the ability to containerize configurations and to have the containerized systems, you now have the Kali Linux and parrotos images, and I'll talk about the difference between images and containers in a second, with full repository support, which means you can easily set up multiple instances of Kali and Parrot, and set them up with your own configuration. You then also have your containerized vulnerable web applications like the OWASP Juice Shop, the DAM vulnerable web application that can be used for training and learning. Right, so you can easily set them up for students if you're currently hosting a CTF, and this will all become apparent when we take a look at the practical aspect here. All right, you then have your pen testing and bug bounty toolkits, which I currently set up. And the reason I set up a bug bounty toolkit for myself with Docker is because whenever I'm performing a penetration test, I usually set up a cloud instance, which means I want the exact same configuration of tools wherever or whenever I set up a new cloud instance. And it was really becoming quite cumbersome installing all the tools manually. Even if I created a bash script to install them, it was really inconvenient because in one event, one application or one script would require a few more dependencies if it was updated. So and around this time I was also using Linux containers quite a bit, and I really liked the application of containerizing environments that you can then deploy on multiple computers, and it will remain the exact same in terms of functionality. You won't have to do anything else. You just plug and play, and you have the exact same toolkit that you had on your laptop at home. Right, and then winding off, Docker is extremely resource efficient, and the tools and images can be easily updated and pushed to all the users who use them. All right, so that concludes the presentation aspect. I'm not going to get started with the practical demonstration, so I'm just going to bring up my VM here, and we'll go into my terminal. So I'm currently running this on a VPS, and the reason for that is because there's much faster internet speed. So again, getting started, we first want to take a look at installing Docker and then enabling the service. So let's do that right now. So I'm currently running Ubuntu here, and you can see my kernel version is version 4.15. This is Ubuntu 18.04 LTS. And let me just clear this up, and I'll increase the size of the font here so that everything is visible clearly. All right, so to install it, we use the aptitude package manager. So you can also use pacman if you're using an Arch-based distribution. So apt install, docker.io, right? And you want to hit enter, and I already have it installed. The second thing you need to do is you need to enable and start the service so that the Docker daemon is running. All right, so we use system control, and you can then say enable Docker, and I hit enter, and Docker is already enabled on my system, so that means it'll run at startup. I highly recommend that you do this if you start using Docker regularly, and then I want to start the service, and then I can say system control status Docker, right? And that gives me the status of the Docker service. You can currently see that it's active, it's loaded and active, and it's running. So that means we can now utilize Docker. All right, so I'll take you through the essentials now. So first of all, let's talk about Docker images and containers, right? So Docker images are essentially just your VM templates, right? So these are environments that are pre-built and can be easily downloaded and then, you know, turned into containers, right? So again, you can find Docker images on the Docker Hub, right? So the Docker Hub is like a repository for all, you know, Docker images that are publicly available. So for example, if I wanted to look for the Ubuntu Docker image, I would simply search for Ubuntu. If I wanted to run a container running Ubuntu, I just hit Ubuntu here, and that will take me to the official Ubuntu Docker page here on the Docker Hub, and it gives me instructions on how to pull this Docker image, right? So let's talk about that right now. So as I said, we have Docker images and we have Docker containers. To view your Docker images, we type in Docker images, right? And that gives me a list of all the images that I have. You can look at your Docker images as ISO files, right? Or installation files for VMs, except they're already pre-configured and you don't have to do anything at all. So a better example or a better analogy of looking at is looking at Docker images as OVA or OVF files for VirtualBox, right? So you just set them up and it's much faster. It immediately sets up the container and you now have an environment. So in my case, I have OWASP Juice Shop, Kali Linux rolling, the bug bounty toolkit that I created, parrotsec or parrotos, and the damn vulnerable web application. All right, so these are the images that I can use to create containers, right? And to do that, if I list my current containers that I have running, and to do that, I type in docker psa, you can see we have 0 containers currently running, which are your VMs now, but nothing is running. And the important thing to take a look at when you're taking a look at your images is you have your repository name and the image ID. So the image ID is a unique identifier that will also be there with containers. You'll have unique container IDs. This will allow you to uniquely identify your images because you can also install various versions of images. So for example, if I say Docker pull, and I'm pulling from the Docker Hub repository, so I say Docker pull, if I say Ubuntu and I hit enter, that's going to pull the latest version of Ubuntu, right? So I'm just going to wait for that to pull, and there we are. So now if I say Docker images to list my images, you can see we have Ubuntu, and this is running the latest version, which is 20.04. If I want to pull version 16.04, I can also do that by saying Docker pull Ubuntu 16.04. And to do that, I would need to use the colon here. So 16.04, and I hit enter, and that's going to pull Ubuntu version 16.04, which means I now have 2 versions that I can set up. All right, so again, Docker images. Let's say I want to run a container, you know, for Ubuntu 16.04. So I'll just copy the image ID here, the unique image identifier. And to get started, if I want to run a container from an image, I simply type in docker run, and then I specify various arguments. So in the case of Ubuntu, this is an environment that I can actually interact with using an interactive terminal or a TTY session. So to specify that I want to interact with this container through a terminal, I type in IT, so that means interactive session, and then I can specify a name for this container. In this case, I'll just call it test, right? And then I specify the container, the image ID, which I just paste in, and then I specify the shell that I want to use. In this case, is going to be bash. I'll just specify the absolute route to bash, and I hit enter, and you'll see now that I'm currently logged in on that container. So this is the Ubuntu container, and I can confirm that by typing in cat etc issue, and you can see it's running Ubuntu 16.04 LTS. So I'm currently in that container, and now because I'm in that container, I can do whatever I want, and this is essentially like a VM, right? And the interesting thing is, remember, it's sharing my host operating system kernel. So it's sharing my host OS kernel, which is version 4.15. Okay, so now I can do, pretty much whatever I want, and it's a fully isolated container or a VM, which means anything I do in here doesn't affect the system. And it's currently persistent, which means this container is going to be saved, and any work that I've done, any files that I've stored on it will be available. So for example, if I just go into my home directory and I say vim test.txt, and I don't have vim installed, so I'll just install that apt. So I'll say apt update and apt upgrade. Let me just upgrade my packages as well. Sorry. Let me just correct that command here. There we are. And then I'll install vim in a second here, and we'll just create a file with a bit of content. So there we are. Just run an upgrade here. That's going to upgrade any of the packages. There we are. And now I can say apt install vim, and that's going to take about 54 megabytes. That's fine. That's going to set up vim for me now, and there we are. I'll just run the previous command where I created the file, and I'll just say this is some text data, and I'll save that. And now when I want to exit from a container, I hit exit, right? And that's going to take me back to my host operating system. So now that we've talked about images, now we have our containers, and to list our containers, we say docker psa, and you can now see, if I reduce my font size, the container is listed here. And remember, we gave it a name, and the name is also specified. So it gives us the container ID and the image that was used to create this container, and the command that we ran with it, which is bin bash, and the status. This is very important. The status tells you whether the container is currently running or is in an exited state, which means it's shut down. In our case, you can see it's telling us that the container is in an exited state, which means it's currently not running. And again, if we want to start up the container again, we say docker. Now we specify the container option. So docker container start, and then we specify the name of the container, or you can specify the container ID. We hit enter. That's going to start it, right? But it's not going to take us into that container or log us into that container. However, if we hit docker psa, you can now see the status is telling us that it's up, right? And it gives you the history of how long it's been up. In this case, it's 9 seconds. If we hit it again, it's now 17 seconds, so on and so forth. So the container is currently running. And to attach ourselves to it, or to log in, or to actually get a terminal session, we need to say docker container attach. Sorry, that is attach here. And we specify the name of the container or the container ID, and that is going to log us in. There we are. So now again, we can check the directory, the home directory where I created the test file, and there we are. You can now see we have the test.txt file that we created. So the changes have been persisted, right? And again, you can also create containers that you can use one time, and then after you're done, or once you exit from the container, it actually just deletes the container for you. And to do that, we use the docker rm command. So again, if I just want to delete this container, so I say docker remove or rm, and I say test, right? And that's going to exit. So now if I list my containers, you can now see we have no containers running. All right. Now that we have that done, we can actually start taking a look at various tools that we can set up now that we understand the basics of using it. So first of all, I want to start off with Kali, and you can find Kali on the Docker Hub. All you need to do is type in Kali, and you're typically looking for the rolling version, which has the latest repositories. Again, so to pull it, you just copy the docker pull command here. And since I already have it pulled, or because it's actually updated, so I'll just pull it one more time just to make sure that I have the latest image. Yeah, so I do have the latest image. So again, running it is very simple. It's very similar to Ubuntu. We simply say run. And now because I want to delete the container once I'm done, I specify IT for an interactive terminal, and then I specify RM. That will ensure that the container is deleted once it's in an exited state, right? And then I specify the Kali Linux image, right? So let me just get the ID of the image, which is right over here. So that is the unique image ID. So docker run IT RM, and I will then want to specify a name here. So again, I'll just specify name, and we'll just say this is a test, and we'll specify the ID and bin bash, right? And I hit enter, and there we are. So now we are currently in the Kali box, and again, I can confirm this by saying cat etc issue. Apologies for that. There we are, cat etc issue, and we're currently running Kali Linux rolling edition. So now that we have access to the Kali repositories, this Kali image doesn't have any tools installed, so you need to configure it to your to what you would prefer. So again, I can say, you know, apt update, and then I can install all the tools that I want, for example. And this is the great thing about running Docker, is the images are lightweight, and you can set up only the tools that you're going to use. So apt install, let's say I wanted to install a few bug bounty tools. I can say I want nmap. Let's see, we can install Fierce as well, DNS enum, and we have GoBuster. And this is the great thing of having the Kali repositories, is you can install all of these tools with one click. And if you run it on a VPS, the internet connection is extremely fast, and you can set all of these tools up relatively quickly. All right, so I'll wait for this to install. So it's installing quite a few tools. And you can see how easy it is for me to set up an instance with all the tools that I need. But this is still cumbersome because I need to install them. So again, if we type in GoBuster, that works. And maybe I wanted to install something like WordPress scan. And you can see it's extremely easy. I don't need to do any setup, install any dependencies. The repositories automatically do that for me. And there we are. It just takes a few seconds. And now I have an environment that I can use, and one that is tailored to what I need, as opposed to, you know, a system that has tools that you probably will not use or will rarely end up using. So there we are. So that's how to use Kali. Now, because I specified the RM option, you can now see that after the container is in an exited state, it is currently not running, which is what it's currently not running. And it got deleted, which is exactly what we want. We don't want a, you know, persistent session of a box that we used for pen testing. So let's talk about parrotos. Parrotos comes with a few tools. As you can see, the size is huge. It's about 4.7 gigs. And again, to run it, we can run the previous command and just remove the Kali ID here and replace it with the parrotos image ID. So there we are, we hit enter, and we're now in parrotos, and we get the familiar parrotos terminal. And we can now, because I think we had the tools installed, nmap is available. We have WordPress scan also set up, so we'll wait for that to load. And there we are. Joom scan, do we have a GoBuster? Let's see if we have GoBuster. So we don't have GoBuster installed. So you might have to install the tools that are currently missing, but Parrot has done a very good job. I'll give them credit. They've done a better job than Kali, because Kali doesn't install anything for you, which I understand. They actually use this for, you know, custom images and solutions that, you know, you might want to use if you're hosting a CTF and you want to install only a certain or specific tools. So again, ParrotOS is quite good. You have access to the Parrot repos. Let's see if we have GoBuster here. So apt, I'm not really sure whether the ParrotOS has the Parrot. Yeah, so you can see in the case of the Parrot of ParrotOS, I've actually updated my repositories here. Let me just update the Parrot repositories, because I think it does have GoBuster. There we are. Yes, so it does have GoBuster. So again, you can install the tools that are currently missing. And both the Kali and the ParrotOS repositories are extremely useful, and they have multiple tools that you can use to set up your own environment and use in pen tests or bug bounty assessments. And it's much better because, you know, for example, in my case, I can have all my tools running in one terminal, and then of course I can run my proxy, which is burp or OWASP shop on the host operating system, and I don't need to use any VMs or anything, you know, like that. That will take up huge amounts of system resources. So this is quite excellent that way. All right, now let's take a look at the bug bounty toolkit, which is the toolkit that I set up and has all of the tools that you'd use in a bug bounty assessment or when you're performing bug bounty hunting. And you can find this on this repository here. So github.com, Alexis Ahmed, and bug bounty toolkit. And again, you can pull the image. You also have the Docker file on my repository, so you can customize the Docker file. The Docker file essentially just contains all the instructions to build the Docker image. So you can see it contains all the tool installation and dependency setups. So again, you can also find this on the Docker Hub. So bug bounty toolkit. I'll just search for it here. It should be the first option. There we are, HackerSploit bug bounty toolkit. And it was just updated a few days ago, and this is the list of tools that it currently has. So you know, bucket finder, DNS recon, dir search, mass DNS, Nikto, recon ng, all set up and ready to go. So I already have the latest version, but I'll just pull it one more time, and we can then start talking about the pen testing environments and setting up your own virtual hacking lab. All right, so now that we have the image, I say Docker images, sorry. My apologies, my keyboard is right in front of my microphone here. So Docker images, and there we are. We have the bug bounty toolkit, so I'll just copy that. So Docker run, I'll just specify the IT option first, and then RM, and we specify the name or the image ID here, and that is IT, and we specify bin bash. I also have a Z shell or these ZSH. So again, bin bash, there we are, and we're now in the bug bounty toolkit. So if I list my current home directory, you can see we have the toolkit directory. I also have the seclist word list configured. So again, if I can run any of the tools that you typically use for bug bounty. So dir search, for example, recon ng is fully set up and can be used without any dependencies needing to be installed. There we are. Also have nmap setup, Nikto, and all of the other tools that you can check out. So again, you can see there's no end to the environments that you can set up with the tools that you require. And there's multiple toolkits out there, you know, for various things like Android, pen testing, reverse engineering of Android applications. So all, you know, tools like APK tool, so on and so forth. Right, so you can see we have plenty of environments that you can set up. Now, the real power of Docker comes from DevOps, right? Because this is where Docker is usually deployed the most. So, you know, DevOps companies or companies that develop web applications, the problem that they usually had was when they sell these web applications to companies, they need to also send installation instructions and setup instructions. Most of you already know this. So let's say I want to buy a web application for my business, and let's say it is a reservations booking system, and so what will happen is the developer will send me a whole list of instructions or installation instructions that need to be done before I can actually set that web app up. You know, stuff like installing PHP, MySQL, Apache, you know, essentially setting up the LAMP stack and then installing all the dependencies, which is extremely cumbersome for customers or clients because it can become, you know, extremely difficult for them to set it up, and they often then have to get the developer to set it up for them. And this wastes the developer's time, and the developer then has to, you know, communicate with the client, and this becomes a real mess. So Docker has really shined in the DevOps community because you can essentially build a Docker image once with all the dependencies that the application needs, and you can deploy it 1,000,000 times without having to set up a single thing. Now, a common example of this is, of course, vulnerable web applications, right? So, for example, OWASP shop, and you can find all the vulnerable web applications under OWASP.org, under Project Vulnerable Web Applications directory, and you have a list of all of them. So you have offline, the online version, so you have the OWASP NetGoat, CloudGoat, like you have tons of them that you can set up to learn bug bounty hunting, to also, you know, set up CTFs. And in the case of OWASP shop, you need to install a few, you know, quite a few dependencies. So again, it becomes quite cumbersome setting it up over and over. And you know, when you're learning, the last thing you want to be doing is taking, you know, more than 1 hour setting up your environment, right? So again, it really is very, very simple. All you need to do is say, docker pull, just pull the image, and then right at the bottom here of the repository, it gives you instructions on actually deploying it with Docker. And in this case, we'll also be exposing this image to the internet through a particular port because it's running a web application. And with Docker images that host web applications as opposed to entire systems, you don't need to interact with them via terminal, because all you need to do is just run them once. And once they're running, you then, because you're exposing the IP onto the internet, you can easily then access it through a URL like so. So again, I'll just pull the image and I'll show you this right now. As opposed to installing, all the dependencies, setting up a LAMP stack, this is how easy it is to do it with Docker. So I pull the image, I say Docker images, and I have the juice shop right over there. I just copy it. So I say Docker run, and then I specify RM. So I want to delete the container once I'm done, or once this is an exited state. And then I specify my port options, right? So the port options are quite simple to understand. The first port that you specify is your local port, so on what interface you're binding to on your host operating system. And then the second port is going to be the container port that you want to expose. In the case of OWASP Juice Shop, the recommended port is 3000 on both ends. So we say 3000, and we then specify the Docker ID, image ID, and hit enter. All right, so we'll wait for that. And it's going to say all dependencies are satisfied. So it gives us some output and tells us the server is now listening on port 3000. All right, so now to test this, what I'm going to do is I'm just going to get my server IP. And again, I can do that really simply. Let me just do that right now. All right, so I have my server IP address, and this is just a VPS, so that will not be available. Once I'm done with it, I'll just delete it after. So again, I'll just hit in the IP here and the port 3000, and there we are. OWASP Juice Shop is set up without installing any dependencies, doing any of the configuration and all of the the deployment deployment techniques, and installing dependencies, setting up the database. And I immediately can host this for a CTF, or if I want to learn about specific vulnerabilities, I can set this up multiple times, right? So I can also set up multiple other containers on other ports. For example, if I go back to my terminal here, and let's say I close this, but before I do that, I want to run this in a detached state. So if I list my my current containers, you see I've exited from the container. So if I reload this, you'll see that this will not be active now. So let's say I also want to run the same image under the port 3000 on and I want to run it in a detached mode so that the container is left running, and I can also deploy other images. So I can say Docker run, specify in a detached mode, and that's going to run it. And now once it's set up, I should be able to access it. So we'll give it a few seconds to set up the environment, because it does need to set up various options in the background. So there we are. And OWASP Juice Shop is now running. And then I can also run my other images like Kali if I'm using the tools there. So I can say Docker run, and again I can then run the Kali image, or parrotos, for example. So Docker run, and I can say IT RM, paste that in there, bin, and bash. And now I can run multiple containers at the same time. So you can see I'm currently running Parrot, and I'm also running OWASP Juice Shop. So it really is fantastic and much more efficient than running multiple VMs, right? So again, I can use this, and when I'm done, I just hit exit, and that container is not persistent, so it gets deleted immediately. I don't need to do anything else. And there we are. So again, the Docker OWASP Juice Shop container is running. So again, I can just get the container ID, and they say Docker container stop, paste in the ID, and I hit enter, and now that container has been deleted because I stopped it, and now OWASP Juice Shop is not running anymore. So it really is quite awesome. All right, that being said, let's take a look at one more other vulnerable environment here, Docker images, and how to set it up, which is the damn vulnerable web application, which really is fantastic. So I'll just search for it right over here, and I'll also show you a few other awesome things you can do with the Docker Hub before we conclude this presentation. So DVWA, right? And I just hit enter, and you have plenty of images that have been set up by many people. So again, if we click on this one right here, which is the one I use, you can see it gives you options as to how you can run it. You can also specify or change the MySQL password. So running it is very, very simple. We need to run it in a detached mode and then specify the port. So again, I'll just say, we'll just say docker run, and I'll just copy the image ID for the damn vulnerable web application here. And I'll say this is going to be in detached mode. And I want to get rid of this container when I'm done, and then specify the port. So before I actually paste in the ID here, I'll just specify the port. So we're exposing port 80 and port 80 there. And we then specify the image ID and just confirm that that's the way to deploy it. And you can also, again, then, expose the MySQL database if you're going to be attacking that as well. So I'm going to hit enter, and that's going to run in the background. So docker PSA. You can see it's been up for 2 seconds and it's exposed on your server port right there. So again, if we just load this on port 80 now, just gonna hit enter. We're gonna give that a few seconds, and there we are. Damn vulnerable web application is already set up, and it's now asking us to create or reset the database. So I'm just gonna say create here, and it's gonna say the database was created, and we can now log in to the damn vulnerable web application. I'm just gonna log in with the default credentials. And I believe they are admin and password, and immediately we have set up a vulnerable web application that we can use for lessons, for learning about vulnerabilities. So for example, command injection. Let's see, if I want to run a few commands here, I can say cat etc password, and you can see it's telling us we've entered the incorrect IP. So if we modify the security here, I just want to demonstrate that you can actually perform these, you can test these vulnerabilities with a high amount of security. So again, we can then say, run the following command cat etc password to display the password file, and there we are. So you can really use Docker in multiple ways for bug bounty hunting and pen testing. In this particular presentation, I've just gone over how to set it up, for how to set up your environment, your tools. And then, of course, I've been talking about how to set up, your vulnerable environments that, again, you can use for lessons and many other things. So again, you have access to multiple vulnerabilities here, file inclusion. Again, so you can click on file 1, and then again, it tells you your IP and stuff like that. So yeah, pretty cool stuff. All right, so thank you very much for having me during this presentation. I really appreciate the welcome. And again, if you have any questions regarding this presentation, you can reach me on Twitter under HackerSploit, and that is you can reach me there and send me any of your messages. If you have any questions, again, you can reach me on my Twitter handle, which is HackerSploit. And thank you very much for watching this presentation. And yeah, have a great day. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Dafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.